Hello. Okay, so here we have x to the fourth divided by x squared minus 3. So to do this with exploding dots in an x to 1 machine, well, here we go. Here is our x to 1 machine where our boxes start with, well, we have our ones box and then our x's box, x squared, x cubed, and x to the fourth in this case. Is as far as we need to go. So to represent x to the fourth, well, that's just one old dot. That's just one dot in our x to the fourth box. There it is, x to the fourth. Now we are dividing by x squared minus 3. So what does x squared minus 3 look like in an x to 1 machine? Well, x squared minus 3. Well, x squared is our third box. So we have one dot in our x squared box. But then we have minus 3. Or we're adding the opposite of 3. So therefore, we have 3 anti-dots. 3 anti-dots in our ones box. There we have it. There is x squared minus 3. So how many groups of x squared minus 3 do we see in x to the fourth? Well, none right now, right? I just have the one dot in our x to the fourth. But what do we want? We want these 3 anti-dots, right? That are 2 boxes over. We want one dot next to an empty box next to 3 anti-dots. That is x squared minus 3. Okay, well, let's go ahead and make it happen. Right? We want something in life. Let's make it happen, but then let's make sure we deal with the consequences. So, what do we want? We want these 3 anti-dots that are 2 boxes over from where our one dot is. So, we have our one dot in our x to the fourth. Let's go ahead and let's add in these 3 anti-dots. 3 anti-dots. There we have one dot next to 3 anti-dots. But I can't just go ahead and put in 3 anti-dots. If I do that, I'll need to add 3 dots as well. Because anytime we have an anti-dot and a dot together in a box, well, they just annihilate each other, right? They just go poof, and they're gone. So therefore, we have here now one group at the x squared level. Here is my one dot next to 3 anti-dots. All right. And remember, it's always at the rightmost box. So this is going to be at the x squared level. All right. There we have it. We have one group at the x squared level. Do we have any more groups? Well, I have these 3 dots here. What do we want? We want, for every dot, we want 3 anti-dots to go with it that are 2 boxes over. Okay, well, we have one dot. Let's go ahead and add in 3 anti-dots to go with it. But when I do that, well, I have to add in 3 dots as well. 1, 2, 3. Okay, but then I have another dot. I want 3 anti-dots to go with it. Well, I better add in 3 dots as well. So I really didn't do anything. So this box is still really empty. But then I have another dot. I want 3 anti-dots to go with it. But to counteract that, I'll have to add in 3 dots as well. All right, so I added in a total of 9 anti-dots and 9 dots. So I really didn't do anything. So box 1 is still empty, but now, look, I have a group here, right? 1 dot, and then nothing, and then 3 anti-dots, and then 1 dot, and then nothing, and then 3 anti-dots, and then 1 dot, and then nothing, and then 3 anti-dots. All right, so there we have 3 more groups at the ones level. Okay, but now what? Now what? Now what? I mean, okay, I have one group at the x squared level, and I have 3 groups at the ones level of the pattern that I was trying to find, but now I have all these dots that are left over at the ones level. Can I make another pattern? Can I make another 1 dot next to nothing, next to 3 anti-dots? Well, how? Right? All my dots are now in my ones box. I think we're done. Are we stuck? I don't know. Let's see. What is this answer? What is the answer? We're saying that x to the fourth divided by x squared minus 3, that looks like this is going to be equal to what? We have the one group at the x squared level. So we have this is equal to x squared, and then we have, well, we have 3 groups, right, at the ones level, 3 actual groups at the ones level. So we have a plus 3. Okay, so x squared plus 3, but then I have these 9 dots left over. What does that mean? Well, that means that I have a remainder. I have 9 dots that are still waiting to be divided by x squared minus 3. Therefore, the answer here to x to the 4th divided by x squared minus 3 is equal to x squared plus 3 with a remainder, so plus the remainder plus 9 dots that are still waiting to be divided by x squared minus 3. So we write that as plus 9 over x squared minus 3, and there we have it. There we have it. Cool. Cool, cool, cool. So yes, we can also easily see remainders when we do polynomial division with this cool exploding dots machine. Take care.